Chris Baines, and I'm an engineer at Google, and I primarily work on the support libraries. So this talk is basically a big jumble of stuff that's been rattling around my head for a while. It's sort of the nitty-gritty of how we implement some of the bits in the support library. And so there's 3 sections. We'll go through them. All of them kind of disparate, so there's no real flow to this talk. It's just like a big sort of knowledge dump on you. I was reminded last night at the speaker's talk about how this time last year I actually missed day 2. And the reason I missed day 2 was because I fell over drunk and knocked my 2 front teeth out. So thankfully this time I still have my 2 front teeth. So let's get into it. So the first section we're going to talk about is about day and night. And day and night was a feature we added to AppCompat in version 24, if I remember rightly. And it allows your app to be themed dynamically based on the time of day. So here, if you open the app, which is a sample I wrote for the design library, if you open the app at lunchtime, sort of 12 p.m., it's light background dark text. And then if you open that same app at sort of 10 p.m., it's automatically changed to be dark background light text. And that's to help sort of reduce glare for people reading sort of at nighttime or whatever. And to use that feature, there are 2 things you have to do. The first thing you have to do is you have to change your theme to extend from theme.appcompat.day-night. And then you need to tell AppCompat what mode to actually use. Use that via the set default night mode API, and that takes one of 4 options. The first option is follow system, and that just tells it to basically follow whatever the system does. Currently, there is no sort of night mode isn't really enabled on the system, so that's just basically light. And then we have auto, which will switch between that time of day, what we just shown. If your app already has location permissions granted, it will use the last known location and calculate some like rough sunset and sunrise times. If it doesn't, it will use some hard-coded values, those being 10 p.m. and 6 a.m. currently, but that's just what it is currently. And then there's the 2 final options, mode night yes and mode night no, which do pretty much what you expect. It forces either night mode or day mode. But night mode has actually existed in the framework since API 8. And that was through these 2 resource qualifiers, -night and -not night. But the trouble is, those resource qualifiers are only actually enabled in a specific scenario, which is this. So this was API 8, and I think that's a Moto, I can't remember what it's called, but it's only when your device is in car mode, which is not Android Auto, it's like the old car mode from like Eclair, and also when it's docked, so it's in one of those docks. And it was primarily added for things like maps, or basically when you're in a car, you don't want this big bright UI showing if it's really dark outside, because it can be distracting when you're driving. So as with nearly all of the resource qualifiers, they're mostly controlled via the configuration class from your resources. If you look at configuration, there's like 10, 11 fields, which control pretty much all of your resources. The one we care about for night mode is controlled via the UI mode field. That controls a couple of things. So you have to mask it. So once you've masked that UI mode int against the mask, you'll then get a value. And that value is one of 3. It's either undefined, which is pretty much the default. So most of your devices will be running undefined now, which means that your -not night and -not night qualified resources are just ignored. They're not even used. And then you have no and yes. And that pretty much does that what you expect. So UI night no means that your not night qualified resources are used, and then yes means your -night qualified resources are used. And so if you think back a couple of slides, you'll probably notice that the variables are pretty close to the AppCompat sort of exposed ones, and that is completely on purpose. AppCompat is basically a small layer above the framework here, which just kind of pushes it and pokes it to make it do the right thing and what we want. So here is basically a big dump of code of what AppCompat actually pretty much does under the hood to force night mode to actually work. It's simplified just for the purpose of this talk, but you get the gist. We get the resources, and then we get the current configuration, and then we update the UI mode int with whatever night mode we want. So in this case, it could be configuration UI mode night yes, or no, or undefined, whatever you want. And once we've done that, we'll then update the resources configuration object, and so it knows about this new configuration that we want. And from that point onwards, all resources which are retrieved from that resources object, you can use those night mode resources. which means that things like anything from values-night or drawable-night or whatever it is, or not night, depending on the value you use, are loaded. And funny enough, that is exactly how AppCompat's theme is done. So if you look actually at theme.appcompat.daynight, which is that first thing we made you do, that is implemented very much just as this. In res-values, the default theme for day-night just points to the light theme. And then in -night, as the override, it points to the dark theme instead. And that is exactly how day-night is implemented. The second section we're going to talk about here is drawable tinting. Now, let me take you back to a time not so long ago, which was Android KitKat. And if you wanted to actually customize the UI, like action bar, tabs, whatever it is, in your app, you'd have to use something like this, which is Jeff Gilfeld's action bar style generator. And so you'd put in the colors you want and whatever sort of theme you want it to inherit from, and it would give you a zip file. And that zip file contained a number of sort of basically resources that you can plug into your app and make it work. Now, this is an example that I actually used from the generator yesterday. And this is exactly the themes and styles that it makes you put in. Now, this isn't a fault of the generator. This is just what we made you do to actually do this. So we've got a theme, and then we've got an action bar style, then we've got another action bar style, pop-up style, list view style, tab style, drop nav style, progress bar style, close button style, and then one more theme just to round it off. That is what we made you do just to change the colors of your app. That is 80 lines of styles, which you don't really want to maintain, and also 26 drawables per density. So that if you imagine your app, you've probably got, I don't know, 4 or 5 density buckets in there, maybe 6, whatever. But that means you're sort of dragging around 150 pings just around your app, which, again, you have to maintain. So that was back in KitKat. And then if we fast forward to Lollipop, which is 1 release, or 2 release technically, we brought the material theme. And as a side effect of the material theme, we also brought a lot of styling improvements to the framework. And so to do that same thing, where you just want to change the colors of your app, basically, we now give you these 3 attributes, which is color primary dark, and then color accent. And those colors will be used throughout the app in specific places, and basically your app would just kind of look good, which means you no longer need to drag around all those pings and those resources. It just happens by default. And at the same time, V21, we also added to AppCompat, which is the whole point of this little section. Now, all of this, well, the majority of these improvements were enabled for improvements to drawables. Specifically, we added 2 abilities. The first is the ability to tint it dynamically, and the second is to be able to reference theme attributes from resource files. Now, if you join those 2 together, that means you can tint your drawables from resources, from colors brought in from your theme, which is exactly what we want. Which is exactly why there were some new APIs added. So if you imagine how you actually retrieve your drawables from resources, you probably use this method, which is resources.getDrawable. And at the same time, we added another version of that method, which took an extra parameter, which was the theme, which is enabled to actually all work. And it was also added to resources compat as like a shim. Now, if you want to know more about the sort of the deep down and gritty about theme.material and how it works and what all the colors do and all that stuff, Alan Viverette and I did a talk at I/O this year called Android Themes and Styles Demystified. If you work with themes or styles, I'd heavily encourage you to go and watch that talk. But back to the actual implementation, to actually get this to work, back to what was then API 7 to 19 in AppCompat. Or as I prefer to think about it, the AppCompat mountain of hacks, which is pretty much what AppCompat is. We try and do the hacks so you don't have to. So when I was trying to think about how we implement this stuff, I come up with a couple of ideas. And I spent at least 3 or 4 weeks trying to get this stuff to work, and I nearly gave up. So the first thing I thought about was, is there a way that we can actually use custom drawable classes? So if you're in your layout and you've got a custom view, you can reference those classes from your layout easily. In this instance, it's my awesome view, but whatever it is. But unfortunately, you can't do that in drawables, or at least you couldn't until N, I believe. Instead, there's a hard-coded list of tags that we look for, and we map those tags to implementations, which means that we couldn't actually do anything custom. They are the tags, anything else through an exception. And then I thought, is there a way that we can actually influence how resources, as in the class, actually retrieves those drawables? Can we hook in and do something fancy? And the answer was also no. So there is no equivalent for layout inflator factory. So there's no way we can hook in. And also, the resources class is pretty locked down. There's a couple of methods that we actually need, well, I would have needed to override, load drawable being the one, but it's package private, so it's pretty much locked down. So in other words, I was up a creek. So if we look back a little bit, this is the drawable, which is used for a button in material. It's pretty simple. It's a shape, which is a white rectangle, with some sort of roundy rectangle even. The important thing to see is that it's tinted. So this is that functionality which was added in Lollipop, which allows you to tint a drawable from your resources and reference an actual theme attribute. This is exactly what we want. Now, if we actually use that in AppCompat, it would throw an exception. But if we ignore that exception for a minute, this is what you'd actually see. So that tint would be ignored, and then you'd just see a white rectangle, which is fine on a dark theme. Well, at least you can see it. But on a light theme, you can't see it. And if you actually look at AppCompat now, it actually works. So what did we actually do? Well, I went back to the drawing board, and I thought, what do we actually have control over? And the only thing we do have control over are views, and that is via layout inflator factory. And what it allows us to do, it allows us to swap the implementation of views underneath you. So if you have this layout here, with a linear layout, and then you've got three views in there, a button, an image view, and a spinner. What actually happens under the hood is you inflate this in AppCompat, and you'll get this instead. Which is why, if you look in Hierarchy Viewer at your app, you'll see all these weird and wonderful AppCompat classes. It's because we're dynamic, well, not dynamically, but at runtime, we are injecting our own views in there, so we can do some weird and wonderful stuff. So what's it allowed to do? Well, the first is that we can reload resources, drawables mainly, and tint them dynamically. Because we know the drawable, which is going to be used for buttons, we can get that drawable again and just tint it to a color that we know, which will be color normal, button normal. The second thing it allows us to do is expose APIs. So if you look at View on V21 above, you have get background tints and get background tint mode and all those. We can and we have exposed those methods all the way back to API, what is 9 now, which is the min SDK. The third thing is that we can add new functionality. And now this isn't just primarily for tinting, this is other stuff. So you think back to vector drawables. They were enabled solely through being able to use AppCompat image view. Then themed adapters for spinners. So we're having a light themed spinner pop-up and a dark themed spinner. That was added in API 23 in the framework, and we managed to backport that to API 9. So all of those were enabled by the fact that we could inject our implementation underneath you. And you shouldn't see any difference, hopefully anyway. And the fourth thing we can do is we can work around bugs. I can't think of any off the top of my head, but we have worked around certain platform bugs for you, so you don't see them. So that's drawable tinting. And then I'm going to get onto the third and final section, which is quite a big section, which is app bar layout and flinging. So you may notice at the top there, it's actually got an AOSP bug at the top. So this is a bug that gets routinely commented on and duped against and all the rest of it. And this was added pretty much as soon as we released the design library, 2-3 years ago, whenever that was. It's easier to show you what it is. So here we have what is Chi Square, the design sample. We have an app bar layout, a collapsing toolbar layout, and a scroll view. And as the user swipes up, they collapse the app bar layout, and they scroll up a bit more. Then they start swiping down, and fling. Now, what you'd expect to see there is that instead of that overscroll glow, you'd see the app bar layout expand again. So like it's one continuous motion. But instead, the user needs to swipe down again as a second gesture, which obviously isn't what we want. It's not great. And so if you have a look at the AOSP bug, there are many kind of thoughts on what the issue is here. This is the one that I see routinely, the fact that when the fling happens, nested scrolling doesn't sort of transfer the velocity across. And that's partially true, But the goal, what we actually want, is that flinging does transfer that velocity. So you see this instead. It actually starts. Yeah. So the user scrolls up, and then they scroll down, and then opens again, which is precisely what we actually want to happen. Actually looks not so different, but when you use it, it makes a huge difference. So before we actually look at the issues around this and what the actual problem is, it's important to look at sort of the basics of scrolling. I'm not going to spend too long on this, but it's important for everyone to get a grasp of this. Primarily, we're going to be talking about on-touch event. So this is just all about touch handling. There is also on-intercept touch event, which is very important when you are implementing a scrolling view, but we're going to ignore that for now because it's not so important for this bit of the talk. But if you're going to implement a scrolling view, you definitely need to know the difference and how they interact. So let's go through a gesture. A user touches down on a view and starts scrolling. So the user touches down. You'll be passed a motion event, and you'll get an action. That action will be action down, because that's what we're talking about. So the first thing that the majority of scrolling views will do is instantiate a velocity tracker, and then we'll add our motion event to it. The reason why we have that will come clear later, but the important thing to know is just always add the motion events to it. And then we'll get the Y value, because we're a vertically scrolling list in this example, and then we'll keep a track of it. Nothing too interesting here. And then the user will start scrolling. That's a really bad animation. And that scroll will be made up of hundreds, maybe even thousands, although it's probably a bit of a stretch, of different events, all of them with the action move. And this is how most scrolling views will be implemented, at least it's like a skeleton. Again, we'll add our motion event to it. We need to keep that up to date. Then we'll get the Y, and then we'll calculate the difference, the dy. In this instance, the user has scrolled 10 pixels up. Once we've done that, we need to actually update the view to show the user that we've scrolled. Here's a very simple implementation of what a list view kind of does. It's a very oversimplification. It just iterates for each children and just moves them all up. And then we'll keep that last motion Y up to date. And then the user will lift their finger up once they've finished their scroll. And at that point, we need to think about flinging, because we don't want the scroll to just stop dead. So this is where the velocity tracker comes into play. We calculate the current velocity, and that 1,000 number that you see there is 1,000 milliseconds. So we want to know the current velocity over the past second, pixels per second. Once we've got that, we can get the Y velocity and then fling if we need to. Here's a simplification, like a very simple sort of implementation of fling. I'm not going to go too much into this. The important thing to know is that we have this overscroll object, and that's provided by the framework, and it basically handles all of the scroll deceleration for you, like the curves. So you don't have to even think about that. Then we have our fling method. That velocity is passed in from the touch handling. We get the scroll range, so we have to know how much we can actually scroll. If you're a list view, it tends to be kind of infinite. If you're a scroll view, it's whatever the excess is. And then we'll call the fling method on that overscroller. The only reason why I sort of highlighted this section is that the parameter ordering is a little bit weird if you're going to do this. So the first two are your current scroll position, X and Y. Then you have your fling velocities, X and Y again. Because we're only velocity scrolling, we just give 0 for the X one. Min X, max X, again, we're only vertically scrolling, so it doesn't matter. And your scroll range, basically how much you actually want to scroll. And then the reason why I've highlighted this bit is that the first two in X, Y, X, Y, X, Y, the last ones, anyway, forget it. Go for these slides, it makes sense. After we've called that fling method, we'll then sort of post invalidation, so we actually get called. So we start triggering that fling and start moving. So once we've called that invalidation, on the next invalidation round, compute scroll will be called. Now this is a method on view, and that is called on every draw. Even non-scrolling objects, non-scrolling views will have this method called. It's called in dispatch draw. What scrolling views to do is basically hook into the draw phase and then quickly move stuff just before the draw happens. So the first thing we do is that we call compute scroll offset on the scroller, and that returns true or false based on whether we need to move or not. If we do, then we actually just move ourselves. So that's the very basics of scrolling as a very oversimplification. Next, we have nested scrolling. And this is something that added in Lollipop And the reasons why were this. Having nested scrolling views was kind of difficult. So if you had something similar like this, an outer scroll view, and then deep down the bottom, you've got a list view. So before nested scrolling was around, what would happen is that depending on where the user actually touched, depends on what actually starts scrolling. So you might have a list view scrolling within it, and it's all a bit weird. So the reason why nested scrolling's kind of come about was this. So material happened. And I'm sure you've all seen this video 1,000 times, but I'm going to show you again anyway. So the user scrolls, they collapse some kind of view, and then it comes back down. So you think about how you might actually implement that. You could hack it around with like a list view and then headers. But logically, what you'd actually want is something like this. You'd want some kind of scroll view at the top, maybe a linear layout just to organize it. And then you have an image view, and then deep down there, you'd have some kind of list view. Because that content below is you don't know how many items you're going to have. It's just phone numbers or emails or whatever it is. You don't want to have that as a linear layout. And so nested scrolling was created to kind of not so much solve it, but at least enable it. Before, we just kind of left you to it and go happy. So what is it? Well, it's an event system. That's all it is. But it's one where scroll events are dispatched up the view hierarchy. It's different to something like an on-scroll listener, because the parent and the child don't need to know about each other. Whereas if you implement something like an on-scroll listener, you need to know that your child is a list view or a cycler view or whatever it is. So that's why it's different. And I spent at least half an hour on this animation, so you can look at it. So as the user scrolls, you get these events, and they just go up, try to show what happens. So if we look at the API, there's a lot of API. Some of it is mostly getters and setters, utility methods. You don't really need to know about those. The important four are these four. There's dispatch nested pre-scroll, nested scroll, nested pre-fling, and nested fling. As you can probably see, there's two sets of two. There's two scroll methods, two fling methods, and then with each of those, the pre and a non-pre. So that's the sending side, which is basically whatever's scrolling. And then there's the receiving side, the parents. Again, they're pretty much mirror image. And you have the same methods on the receiving side. There's two things that I'd say you need to know about the API. The first is the relationship between the sending and the receiving side. We've pretty much just covered that. But whenever a dispatch nested pre-scroll is called, the on-nested pre-scroll on the parent is called. And the same happens for all the other three methods. And then there's the difference between pre and non-pre. So what I like to think about them is pre-methods allow a parent to consume events. You'll see in a bit when we actually go for the touch events. But when a scrolling view is scrolling, a parent can consume any of that event. Anything that the parent doesn't consume, the view then scrolls itself, and then the non-pre method is called. So pre is not, a consume event, and then non-pre are the observational events. So let's see how it actually happens. So we're going to go back to our touch events. So user touches down, and then here's the code. Nothing's really changed here. The only addition is that when the user touches down, we call start nested scroll, as if to say, we are going to start a nested scroll. And then once that is called, we will traverse up the tree. Well, the framework will for you. It will traverse up the tree until it finds a parent. And so on start nested scroll, we call on every parent up the tree until one returns true. Once it returns true, it then it's basically saying, I want to be notified of all touch events, all nested scroll events from that point onwards. And it's given some parameters, which are basically the scrolling views or which way it's going to scroll. As soon as one returns true, on nested scroll accepted is called, as if say you're the chosen one. You are going to have scroll events from now on. So great. And now the user starts moving. So they start moving their finger and scrolling up. So this is probably the bulk of where the changes are when nested scrolling come about. The first thing to note is that we have this interarray at the top of your class. And the reason why this was added is that we obviously can't return multiple values from a Java method. So we have to pass this int array with just a length of 2 through the method, and the parent can then put its whatever is consumed into it. So it's to work around the fact that we can't have multiple return methods. So the first thing we do is that we calculate the dy, which is grayed out, but we calculate that dy, which is -10, same example as earlier. And then we're going to call dispatch nested pre-scroll. So this is the thing that happens before we've actually done any of the scroll movement. So it allows the parent to consume some of that event before we've actually done anything. So once that is called, the parent, which is actually listening for those scroll events, its onNested pre-scroll method is called. So here you can actually do whatever you want with that value. We get a value of -10 for dy, but the parent can do whatever it wants, pretty much, as long as it doesn't go over -10. So here I've just added an example method called do something with prescroll. App bar layout will actually move itself. That's an example. And once it's done something, it calculates how much of the event it is actually consumed. So in this particular example, it's -3, and it writes that into that int array. And that's the result, basically. So once we go back down to the scrolling view, it will then check that int array to see what the parent has consumed, and it will minus that value from whenever it's calculated the user has touched. So -10 minus -3 equals -7. So that means that the remainder of the scroll event is -7, which is what the view can then actually scroll itself with. And it will move its children or whatever it needs to with that. I've omitted that section. And the final bit we need to do is that observational event. So we'll call dispatch nested scroll to tell the parent that we have scrolled -7. And the onNested scroll method on the parent will be called. And then the user will lift their finger up, as we've already seen. And the same thing pretty much happens. We need to calculate whether a fling is going to happen, so we get the velocity. Nothing's changed there as such. The difference is that we need to do the pre-fling and the fling method to actually check if the parent wants to consume it. So we'll have that velocity, and we'll call dispatch nested pre-fling. Once that's been called, it will go up to the parent, and it will call the parent's onNested pre-fling method. Now, the difference here between the scroll and the fling is that the fling is a one-time shot. Once the parent has had this method called, it either returns true or false. If it returns true, it is then responsible for the whole fling. The view just stops still. It's just given the velocity, and it can do what it wants with it. If it returns false, the view just carries on. So that's pretty much the problem here. If you think back to the example of what it currently is the reason is because the parent either gets a one-shot deal of whether it wants to handle that fling or not. If it doesn't, and it just lets the view do it, then the view will fling itself, and it will call the observational event dispatch nested fling. Once those have been called, it's important to know that nested scrolling is finished at this point. So even though the view might be moving, or I don't know, the parent's handling or whatever, by this point, the user has lifted their finger up, which means that nested scrolling is finished, which is why stop nested scroll is called. So we think back to our problem. The problem isn't really that flinging doesn't transfer over velocity. The problem is that we can't intercept a fling while it's happening. It's pretty much the problem. Which is why we've kind of come up with something else called indirect nested scrolling. Great name, right? So one thing to know that this is very much work in progress. The code hasn't been submitted yet, and it may not even land. But I'm kind of tired of getting the same question over and over again. So I'm just trying to put this out there to show that we are working on it, and it's something we're trying to fix. But it's not an easy problem. So we go back to nested scrolling slightly. You think back to what it is. It's when the user is directly touching the screen. So the events are only sent when the user is actually have their finger on that screen and they're moving. So I like to think now of nested scrolling as direct nested scrolling. But there's also a lot of situations where the user isn't touching the screen, where a scroll can still happen, which is why it's called indirect. And those situations would be something like this, settling from a fling. The whole problem we're trying to fix is when we have a fling and we're trying to actually handle it. But there's also other times, maybe when you actually set the scroll position programmatically. So if you call set selection on list view, or whatever the recycle view version is, those won't actually dispatch nested scroll events. They'll just move themselves, and then any parent won't actually know about it. There's also things like scrolling from key events. So I think it's like Android TV with D-pads, or even accessibility services, talkback, when you start doing that. Those events are still scrolls. It's just nested scrolling isn't called those times either, so we don't know about it. And there's probably a lot of other examples which I can't think of now, but there are lots of places where it's applicable that we should probably fix. So if we have a look at our very, very work-in-progress API, you're probably getting deja vu because the API looks exactly the same as what you saw earlier. The only difference is that we have this new keyword, which is indirect. So that's the sending side, and then we also have the receiving side, which again looks very similar to what you saw earlier. And that is because the API is mostly the same, and that is completely on purpose. They do mostly the same things, they just call it different times. But there's two things to know. The first is that we're not, probably anyway, not going to have any fling methods in there, because the whole thing we're trying to fix in the first place is flinging. And the second is that it works with nested scrolling. It doesn't replace it. It doesn't override it or whatever. They tend to work at the same time, or at least one after the other. Right, so let's go back to our touch events and show you how it kind of works. So ignore that first bit. So the user touches down. At this point, we'll call start nested scroll, so nothing's changed here. User will start scrolling, we'll be dispatching pre-scroll events and scroll events. Nothing's changed. And then the user lifts their finger up, at which point we'll call stop nested scroll, because again, nested scrolling only happens when the user is touching. We'll call fling, and at this point is when nested indirect scrolling comes into play. So fling will call start nested indirect scroll, so we're telling the parents that we might be moving, but the user isn't touching the screen. And then the fling starts happening. Now, during this fling, we are continually sending indirect pre-scroll events and indirect scroll events. So they just keep pumping away. And this allows the parent to actually consume those events and do what it needs to. In this case, app bar layout is moving itself down. And then as soon as the fling finishes, we call stop indirect, nested indirect scroll. So at that point, indirect scrolling is finished. So here is the full demo in all its glory. Yeah, great, right? As I said, this is very much work in progress. It's currently only implemented in the support library. I need to actually move it over to the framework. And it will be hopefully it will be in a future platform release. Hopefully you've enjoyed my talk. That is me over and out. We should have some time for questions if anyone wants to ask them. If not, come and find me later when I'm having a coffee. And feel free. Thank you very much.
There's no getting over, there's no getting over, there's just no getting